56. Let's read it. Wavelength of a sand particle moving with 100 meter per second speed is. We are given with the mass of particle which is 6.6 milligrams, and we are also given with the value of h, which is Planck's constant, which is equals to 6.6 into 10 to the power minus 34 joule second. So student, let's solve this question. According to de Broglie equation, lambda is equals to h upon mv, the value of h, which is equals to 6.6 into 10 raised to the power minus 34 upon mass, which is given 6.6, but we have to take mass in kilograms. So I'm writing 10 to the power minus 6 kilogram multiplied by velocity, which is 100 meter per second. So 100. Student, let's solve this question. Then the value will be 10 raised to the power minus 30 meter. That means the correct answer is option number 1. Moving to next question, which is question number 57. The ratio of second orbit of helium ion to that of third orbit of beryllium 3 plus ion is. Student, as we all know that radius of an orbit is directly proportional to n square upon z. So here radius of He plus, we have to identify the radius of second orbit. So directly proportional to the value of n is 2. So it will be 4 upon the value of z for helium is 2. And now I'm taking radius for Be3 plus ion. Here we have to identify the radius of third orbit. That means 3 square is equals to 9 upon the value of z for Be is 4. As we have to identify ratio, so ratio of He plus upon ratio of beryllium 3 plus is equals to 4 upon 2 upon 9 upon 4, which is equals to 8 upon 9. That means the correct answer is option number 4. Moving to next question, students, which is question number 58. Let's read it. If the energy of electron in first orbit of hydrogen is minus 13.6 electron volt per atom, then energy of electron in fourth orbit of He plus ion in electron volt per atom is. Student, energy of electron in the nth shell is equals to minus 13.6 z square upon n square electron volt per atom. Here we have to calculate energy of an electron in the fourth orbit for helium plus ion, which is equals to minus 13.6 into z square. The value of z for helium is 2, so 2 square is 4 upon n square. N here is 4, so 4 square will be 16, which is equals to minus 3.4 electron volt per atom. That means the correct answer is option number 1. So here I'm writing answer is option number 1. Moving to next question, which is question number 59. Let's read the question. Wave number of first and last line in Balmer series respectively in hydrogen atom are, where R is Rydberg constant. Student, the formula to calculate wave number, which is nu bar, is equals to 1 upon lambda, which is equals to RH z square 1 upon n1 square minus 1 upon n2 square. Here we have to calculate for hydrogen atom. That means z is equals to 1. Also we have to calculate wave number of first and last line in Balmer series. For Balmer series, n1 is equals to 2. Now student, first we will be calculating for first line. For first line in Balmer series, n2 is equals to 3. So nu bar is equals to R, because the value of z is 1 and the value of RH here we have to take R 1 upon 2 square minus 1 upon 3 square, and the value will be 5R upon 36. Now student, let's calculate for last line. So for a last line, n is equals to infinity. Now n2 is equals to infinity. So nu bar is equals to r 1 upon 2 square minus 1 upon infinity square, which is equals to r upon 4. That means the correct answer is option number 1. The wave number for first line in Balmer series is 5r by 36, and the wave number for last line in Balmer series in hydrogen atom is r by 4. So the correct answer is option number 1. Moving to next question, which is question number 60. Let's read it. Total number of nodes in 4D subshell is. Student, the formula to calculate total number of nodes is equals to n minus 1. Here the value for n is 4. So 4 minus 1 is 3. That means the correct answer is option number 4. Moving to next question.